Welcome to today's lesson on graphing systems of linear inequalities. Yesterday, if you remember, I taught a lesson on graphing just one singular linear inequality, and today we're going to talk about what a solution to a system of inequalities looks like. And right now, you already know what a system of linear equations looks like, so kind of a quick refresher here. If I would graph a system of equations, it would look like this, and we always said that the solution was at that one exact point where they cross, so it had usually just one answer. Occasionally we would have two lines that were parallel. If that was the case, there was no solution because they never crossed. And on the rare occasion when we would have the exact same line on top of each other, we said that that was infinitely many solutions. All the points that occurred on that line were a solution. Okay, so that was, again, a quick review of what a solution to a system of equations looks like, but today we're going to focus on what the solution looks like for a system of inequalities instead. All right, so we're just going to jump right into the examples because we're going to be following the same notes, the steps from yesterday. All right, so we have, instead of one linear inequality, we're going to have two. So I'm going to graph the first one in green here. So it starts at the y-intercept of 1. It has a slope of 1. So up 1, right 1, up 1, right 1. And if you remember from yesterday, I told you don't connect the points right away. Look at your inequality symbol. We have a less than. It's not equal to, so that means we had to make a dotted graph. Okay, and then we had to shade. So the shading was based upon your inequality. I told you this was kind of the shortcut yesterday. So we have a less than symbol. Less, you think down. So I'm going to pick a point and shade below. So in this inequality, we would shade below that line. All right, so let's now do the other one. I'll do this one in pink. And it's going to start at -1, so I'm going to go 1 down. The slope is -2/1, so I would go down and to the right, or I'd go up and left, and it is going to be dotted. All right, here, if it was an equation, a lot of you guys would panic and say, well, it doesn't cross right at a point, it crosses in the middle of a box. That would be true if it was an equation, but with inequalities, that point doesn't necessarily matter. And I'll show you why here in just a second. So I'm going to finish this. I did dotted because it wasn't equal to. Now I'm going to look at my symbol. It's a greater than symbol. So greater than, you think up. So pick a point, and I'm going to shade up. So that would be in the kind of the right half of this graph, and I'm going to just kind of change the direction that my graph is going. If you were in class, we did this with highlighters today or yesterday for you guys. And so it was kind of easier to shade. So if I was doing both of these and I had two highlighters, where they overlapped would be obvious because it could kind of change colors. If you're at home, you could grab a highlighter, or you could just do what I did and kind of make your lines going different directions. Now, if you remember, a solution to a system is a point that has to work for both of our inequalities. Okay, so I'm looking for where are the points that will work for both of them when I plug them in. And so that is the area where they overlap because both have to be shaded. So I'm looking for where pink overlaps green, and that is then this portion of the graph. So sometimes I'll go over it a little bit darker, especially if I don't have a highlighter. But this would be the solution to the system of inequalities. So all of my answers are in that shaded area. So I could even ask some follow-up questions. I could say, is this point a solution to the system? Answer is no. Even if I put it in this shaded area, is that a point a solution to the system? The answer is no, because it was only shaded in the green area. It has to be where it's shaded in both areas. So the only points are in that black shaded area. Those are the only solutions. Okay, so let's try another example. Okay, I'm going to do the first one here in blue. I'm going to go down 2, and I'm going to go up 1, right 3, down 1, left 3. This one was equal to, so that means solid line. The symbol was a less than, you think below. So I'm going to shade here below this graph. All right, next one. I'm going to put this in pink. This is a special one. I know it's special because there's only one variable. Okay, so for those of you who are still struggling with these, pick points where the y is -3. And just randomly choose your x's. I'm going to choose small ones. So 1, 2, 3, and plot those points. So 1, -3 would be right here, 2, -3 here, 3, -3. Notice that makes a horizontal line. So now ask yourself, should it be solid or dotted? Well, equal to, so solid. All right, now how do I shade? Greater than symbol, you think shade up. So I'm going to shade everywhere above that pink line. And our solution, again, is where the two overlap, where the blue overlaps the pink, and it would be in just this little triangle area. That would be where my solution is. All right. We're going to try 2 more, and then that's going to be it for the lesson. All right, so I tried to pick ones that sometimes people get confused on. So let's start with y is less than x. Some people think this is a special one. Not special, because we have 2 variables. So that means we have a slope, which is 1x, and we have a y-intercept. It's not there, so it's 0. So I'm going to start my graph at 0. I'm going to go up 1, right 1, up 1, right 1, or down and left. It is less than, not equal to. So what that means is that it is a dotted line. And since it's less than, you think shade below that line. All right, I'm going to do the next one in blue here. Again, not a special one. We have 2 variables, a y and an x. So our slope is -2/1. Don't have a y-intercept either, so it also starts at the origin. But this time my slope is -2, so I'm going to go down to right 1, down to right 1, and up and left, up and left. It is a greater than, not equal to, so that means dotted again. And since it's greater than, we think shade up. So in this case, it'd be kind of the right side of this blue line. And our solution to this system is where the 2 inequalities overlap. So it is in this right half of the screen over here. That would be the solution to the system. All right, one last one. And if you haven't realized the theme yet today, it is crazy hairstyles. So we're going to start with the first one here. I'm going to start up at 3. My slope is 1/2, so up 1, right 2, or down 1, left 2, down 1, left 2. This one was equal to, so that means solid line. We see that symbol, which is a less than symbol, so that means we're going to shade everything below that. All right, now this one was the only one on the entire examples that was not in slope-intercept form. Okay, so we're going to have to do some work on this one and rearrange it. So I want to get my -2y by itself. So I'm going to move this x to the other side by subtracting x. All right, so that will give me -2y is less than -x plus 2. All right, here's the part you have to be really careful with. I am going to divide by that -2, and don't forget, when you divide by a negative, we have to flip that symbol, so it less than turns into a greater than. Other tricky parts, don't forget there is a 1 in front of that x. So that would be a 1/2, and again, a negative divided by a negative is a positive 1/2. Okay, 2 divided by a 2 is 1, but since it's positive divided by a negative, it would be a -1. All right, so let's graph this last one. So go down 1, up 1, right 2, up 1, right 2, or down 1, left 2, down 1, left 2. It is not equal to, so that means dotted. And greater than means we're going to shade above. So if I was shading above this line, And then we always ask ourselves, well, where did these two graphs overlap? Well, the purple one was going down, the blue one was going up. They overlapped right in the middle. And this one's kind of cool. In fact, that's a little, I don't know if cool or different. I think it's cool. So I know anything inside of there is a solution. So if I put a point right here, I know that that's going to be a solution. In other words, if I plug in the ordered pair into my inequalities, it would work. Now, here's the part that people find tricky if a point is on the line. So if a point is on this top line, would it be a solution to our systems? The answer is yes, because that was also shaded in. When you have a solid line, it's part of our answer. But when we have a dotted line like the blue one, it's not part of our answer. So if I would choose the point 0, -1, and if I would try to plug it in, it wouldn't work on both of them. It would work on the top one actually, but it wouldn't work on the bottom one. And if you want to try it out, go ahead and try it out. So be very careful with the solid versus the dotted, because solid, those are part of the solution. Dotted, not part of our solution. All right, hopefully you guys found this lesson helpful. Again, if you have any questions, don't hesitate to reach out through Schoology and send me a message. Miss having you guys at school. Hope to see you soon. Bye.